Hello, Richard. You are the Associate Vice President at IDC. You are a recognized expert in IT research and digital transformation. And you have worked a lot on interoperability, security, cloud deployment, IoT integration, data governance, other stuff probably as well. But you also bring deep insights into the data economy and sustainability. And today I want to explore those topics a bit with you and see how they can shape the future of data ecosystems. So, Richard, welcome.
Thank you.
I find you to have a quite unique background with the combination of research, economics, and hands-on experience in enterprise systems. What drew you to focus on interoperability and that data-driven transformation?
Well, I actually started out as a software developer, so I spent a long time developing software. And as you know, with software development, anytime you have some command like go fetch something, and you get unexpected errors, and it's always unrecognized data. And it's something that seems pretty easy sometimes, but actually it can be quite difficult, and it really changes the nature of software development. Interoperability reduces the software development time and the efficacy of the software that you do produce.
Yeah, I think you kind of touched upon it already, but from my experience, interoperability can have a bit of a perception of being quite difficult to implement, especially for like the individual developer that needs to handle like a more, let's say, unified, structured thing that they need to tackle. But it's at the same time, it can also be seen as like a strategic enabler. It's a goal you want to achieve as an organization. Why is it so critical for an organization to be interoperable today? And what is the reason that you would want that?
Okay, so first, it's difficult to manage interoperability just because code is complex. Most large enterprise systems have millions of lines of code. And to find the exact place that some data created a difficult situation is often quite complex. For example, I worked in the healthcare area for a long time, and we had developed the healthcare record, the patient record, and we found that one disease was not coming up in the system. We were using standardized SNOMED semantics for this, but for some reason we could not import it into the SQL engine that we were developing. And it turns out that after a long study, and it was several people, that it was just a character that SQL wasn't able to manage. Mm-hmm. So it was the fact that there were two doctors that had developed this disease. We had the wrong conjunction between the two doctors, and it didn't like that. So finding that error just took so much time and so many resources that if we had had better interoperability, we probably would have spent less time. So developing code, on the one hand, is quite important. The reason it's so difficult to implement is essentially that if you work in an organization, you know what you think about data or systems. You know how to call an apple. An apple is an apple in your organization, but it may be a pomme in the French system. Yeah. And the interesting thing about interoperability and the semantics that define the objects in software systems is that there are many of them. And it's difficult to implement because enterprise systems, first of all, or large cloud-based systems like CRM or ERP systems are very expensive. And a company has invested quite a bit of money when they come to the point of implementing it. Only about 20% is going to be costs for the licenses of that. The rest is internal change management, implementation, hardware, updates, customization, and these types of things. When I've invested all of that money to call something a POM, and you come and tell me, no, I'm using this interoperability, this semantics, and it's called an apple. I'm probably going to say, no, it would cost me too much to actually change it in my system to call it an apple. I'm sorry, to call it an apple where I call it a POM.
Yeah.
Okay, and so it's a cost thing, essentially. It's difficult to implement because many different organizations have developed many different semantics organization, the organization of semantical concepts and interoperability and exchange and security and various governance things, and they're not willing to do it because they're not willing to exchange data with you just because the cost of doing so would be more than the benefits that they would receive from exchanging data with you, or at least they believe that.
Yeah. If they believe that and we tend to disagree on that, how can we convince them that the benefits outweigh the cost and that participating in a data economy can be beneficial for those companies?
That's the key. We've got to show people the economic advantages to investing money into interoperability. So if people understand that they can improve their, for example, production process, manufacturing process by using training data that comes from another system, and it will reduce their defects by a certain percentage, which correlates to an economic advantage or money that is superior to the cost of actually implementing this, the interoperability, then they will do it. If they don't understand the economic model, they won't do it.
Yeah. So then, Richard, how do data spaces play into that?
Data spaces are a key enabler of the interoperability and data exchange model that we're all currently working towards. Essentially, it is pooling our resources and pooling our knowledge on interoperability. And at the end, a company will not simply choose your interoperability, your data exchange approach. Companies will want to use their data exchange approach. Federated approaches have been coming on board, like data spaces, because of the fact that companies can bring their own standards and their own governance mechanisms and exchange data by having a data space which recognizes their standards and their interoperability mechanisms.
So it's not being too overly ambitious to try to put everything into one mold and respecting the systems that are already being used by organizations.
Exactly, just because companies won't do it. And if we don't have the economy with us, maybe we found the best way to exchange data and the most efficient, but if companies won't buy in, it's completely useless. So if we allow them to bring their own kit, they will participate.
What do you see as the biggest challenge in implementing data spaces and making the data economy thrive today?
I think the biggest challenge is actually time. We have to take advantage of the availability of the data and the willingness of the participants in Europe to use data spaces now. So if we don't, other parts of the world will, because these data exchange platforms already exist in other countries.
What can we do to accelerate that?
I think we can demonstrate through piloting activities the large number of components that exist through tenders like the simple components, or the various data spaces that exist today.
Reuse what already exists and try to build on top of that to go faster, basically.
Correct. Demonstrate it. Demonstrate it to the participants in the data space, because if people see something working, they're more likely to want to try and use it.
Yeah. Looking ahead on accelerating the implementation of data spaces, how will emerging technology like AI and the IoT and cloud shape the next generation of that? And what does that bring for interoperability?
That's the really exciting thing. I told you before about finding the little bug in the SQL that we were working on earlier that affected our software development. AI is really good at finding those types of issues, and it will speed up and probably automate all software interoperability in the future. It will automatically recognize that this sensor is from that type of factory. It speaks this language, it provides data in this format, it has this kind of security, and it will tell you how to transform that also. And in fact, it will actually do that transformation for you. So I think that AI is probably the most exciting area. It's a bit worrying, but guys like me won't be needed anymore.
Yeah.
But
yeah, something to look forward to, I guess. To conclude, Richard, if you could give one piece of advice to policymakers today, both business and tech leaders, what would that be?
I guess it would be follow the money. We have demonstrated through the data market study that the data economy in Europe is about 5% of GDP, whereas the data production in Europe is about 13% of world data production. So what is happening to the rest of that data? Where is it being monetized? It's being monetized principally in the US. And if we look at 5% of the GDP and what we think that is, it's similar to agricultural production and food transformation. So some people say that data is like oil, but mineral extraction is and petroleum production is only about 1.5% of the world economy. So the agricultural production and food transformation being somewhere around 5% is similar to the monetization of data in Europe. So for Europe, data is not oil, it's bread.
I think that's a great analogy to conclude there, Richard. I want to thank you a lot for your insights that you have given me today. And yeah, thanks a lot for the insights and the chat.
Thank you very much.